Deep beneath the North Atlantic, a submarine's sonar picks up something impossible. It's not another sub, it's not a surface ship, it's a plane flying overhead, and somehow they can hear it through hundreds of feet of water. Welcome to the world of the Soviet NK12, the loudest aircraft engine ever built. This engine would power cargo planes, passenger airliners, even experimental sea-skimming craft. But it's on one aircraft where the NK12 became famous, the Tupolev TU-95 Bear. This is the story of a machine that broke every rule of aviation. It's about a turboprop engine so powerful and loud that it became the soundtrack of the Cold War. In 1952, when the world was racing toward jets, the Soviet Union did something that seemed nuts. They built the biggest, most powerful turboprop engine anyone had ever seen. While America was perfecting sleek jet bombers, the Soviets went entirely against the grain. They looked at the future of aviation and said, "Nah, we'll make propellers work better than anyone thought possible." The NK12 wasn't just an engine, it was a statement. We will shake the very air itself. This thing pumps out up to 15,000 horsepower per engine in its most powerful variant. That's enough power to run a small town. They stuck 4 of these monsters on one aircraft. 4 Kuznetsov NK12 engines, each spinning massive 18-foot 4-inch propellers in opposite directions. Most countries were ditching propellers as outdated tech. The Soviets doubled down. They took everything engineers thought they knew about propeller aircraft and tossed it out the window. 4 engines cranking out up to 15,000 horsepower each means up to 60,000 total horsepower. Think about it. That's like strapping 60 Formula 1 cars together and making them fly at 500 miles per hour. Each NK12 drives 2 sets of propellers. And these aren't your garden variety propellers. They spin at 736 RPM. Doesn't sound like much. Here's what that actually means. When cruising down the highway at 60 miles per hour, you're moving at 88 feet per second. These propeller tips move at over 720 feet per second, more than 8 times highway speed. At top speed, the propeller tips actually go supersonic, breaking through the sound barrier. Most propellers become useless once their tips hit the speed of sound, efficiency tanks. But somehow, the NK12 makes it work. Picture 8 massive blades per engine, each slicing through the air hundreds of times per minute. The sound? Like a jet engine fighting with a chainsaw and winning. People describe it differently. Some say it sounds like the sky tearing apart. Others compare it to standing inside a giant blender full of gravel. Once you hear it, you never forget it. Why build something this loud and aggressive? Cold War paranoia. In 1950, Joseph Stalin had a problem. America had the atomic bomb and long-range bombers to deliver it deep into Soviet territory. The Soviet Union was stuck. Their bombers couldn't reach America. They needed a solution fast, their own strategic bomber. The problem was that jets burned way too much fuel for long missions. A jet bomber might reach America, but it would run out of fuel over the Atlantic when coming home. The Soviets needed something that could haul a nuclear payload to America and back. The solution had to be brutal and effective. No room for elegance or quiet operation. This was about survival. A team of Soviet scientists and imprisoned German engineers developed what became the NK12. Ferdinand Brandner, who had worked with Junkers, led the Germans. The Germans brought advanced turbine tech. The Soviets pushed them to make it work, whatever it took. This wasn't just engineering. This was a weapon forged under pressure. The future of Soviet air power depended on it. The engine needed an aircraft worthy of its power. What they built was the Tupolev TU-95, codenamed Bear by NATO. This aircraft breaks every rule in the book. It's the only propeller plane with swept wings ever mass-produced. Swept wings are for fast jets. Propellers are for slow aircraft. The Tu-95 combines both, creating something that looks like it belongs in a sci-fi movie. Engineers had to solve problems no one had faced before. How do you mount massive propellers on swept wings? How do you balance an aircraft that wants to go fast but uses propellers? The Tu-95 became one of the fastest propeller planes ever built, hitting over 500 miles per hour. Most World War II fighters couldn't go that fast. This massive bomber, weighing as much as a loaded Boeing 737, can outrun fighter planes from just a decade earlier. The Bear is massive, over 160 feet long, with a wingspan just as wide. Those swept wings angle at 35 degrees, designed for speeds no propeller plane should reach. The whole design basically gives the middle finger to conventional wisdom. Aviation experts said it couldn't work, but somehow it does. Even today, a Tu-95 on the ground looks wrong. It's like someone took parts from different aircraft and forced them together.
The NK12 engine is an engineering monster. It compresses air through 14 separate stages, squeezing it harder and harder until it's screaming hot. Think of a bicycle pump. When you compress air, it gets hot. Now imagine doing that 14 times in a row, each stage making the air hotter and more compressed. This engine weighs over 5,000 pounds and stands as tall as a person. 4 of these beasts hang from the Tu-95's wings. Each engine is basically a controlled explosion that never stops. Hot gases spin turbines at thousands of RPM, driving compressors that suck in massive amounts of air every second. Every second, each engine inhales 143 pounds of air, compresses it, burns fuel in it, and spits it out the back, like breathing in a full-grown person every second. Each engine has 8 propeller blades total, 4 in front, 4 in back, spinning opposite directions. 8 blades per engine, 32 blades total. Each one built to slice through the air at incredible speeds, tips approaching the speed of sound. Every blade gets individually manufactured and balanced. They're made from special aluminium alloys that can handle incredible stress. A single blade is precision engineered and expensive to replace. The engine also produces jet thrust from its exhaust, combining propeller efficiency with jet-like power.
But it's the sound that makes the Tu-95 truly unforgettable. This isn't just aircraft noise, this is something else entirely. US submarines can hear a Tu-95 flying overhead through their sonar, through hundreds of feet of water. Water carries sound well, but this is still remarkable. The sound is so intense it cuts right through the ocean. The Bear is one of the loudest military aircraft ever built, announcing its presence from miles away. Imagine a rock concert that never stops, flying overhead at 30,000 feet. That's what people on the ground experience. During the Cold War, when a Tu-95 approached Allied airspace, everyone knew it was coming. Fighter pilots would hear that buzz long before they saw the aircraft. Sometimes the sound arrived before radar contact. Ground stations would hear the aircraft before seeing it on their screens. Fighter pilots describe physical discomfort when flying close to a bear. The sound doesn't just hurt your ears, it vibrates through your entire body. The sound became so well known that intelligence agencies could identify individual aircraft. Each Tu-95 has its own acoustic fingerprint. Soviet engineers prioritized power and range over quiet operation. The loudness became part of its reputation. The NK12's power comes from its contra-rotating propellers. While most aircraft use single propellers, the NK12 uses 2 sets, spinning in opposite directions. Most people think propellers just push air backward, but they also create a spiral of rotating air behind them. This spiral wastes energy. It's about extracting every ounce of energy from the air. The first propeller churns the air. The second propeller, spinning in the opposite direction, captures that churned air and uses it for more thrust. Like having two engines working together instead of one. Huge efficiency gains, but enormous complexity. There's a price. These systems cost way more to build and maintain, and are unbelievably noisy. That's why hardly anyone else uses them. The noise isn't just doubled, it's multiplied. Two sets of propellers create interference patterns in sound waves. Sometimes they cancel each other out. Other times they amplify each other, creating sound spikes that can be physically painful. The Soviets prioritized performance over noise reduction, and the intimidation factor became an unintended benefit. The gearing system that makes this work is incredible engineering. One turbine spinning at thousands of RPM has to split power between two propeller sets. They spin in opposite directions at different speeds, and the whole system has to maintain perfect timing.
Flying in a Tu-95 isn't a job, it's an endurance test. Picture sitting inside 4 thunderstorms for 12 hours straight. The cabin is pressurized, but there's no escaping the sound. It goes through everything. The noise isn't just loud, it's physically exhausting. Crew members wear heavy-duty headphones and still struggle to talk. But crews adapt. After years of flying these beasts, Bear crews develop an uncanny ability to detect problems by sound alone. A slight engine pitch change that would disappear in the chaos becomes clear to experienced crews. They spot problems ground techs miss. Everything shakes. Coffee cups rattle off tables. Instruments blur from constant trembling. Even with modern upgrades, the Tu-95 feels like it's about to shake apart. Writing reports during a flight is nearly impossible. The vibration makes your handwriting look like a kid's scribbles. Maintaining an NK12 is like performing surgery on a hurricane. Ground crews wear double hearing protection when these engines run. Safety rules are strict. Workers are limited in how long they can stay near a running engine. They rotate in shifts to prevent hearing damage. The engines consume massive amounts of oil. During long missions, the Tu-95 burns through enormous amounts of lubricants, keeping those massive gears and bearings running. Oil consumption is monitored constantly during flight. Running an NK12 without enough lubrication would be catastrophic. After 70 years of service, these engines keep running. It's Soviet over-engineering at its finest. The Bear's sound sparked countless international incidents during the Cold War. When you can hear something from dozens of miles away, diplomatic tensions rise fast. Sound travels differently depending on the weather. Bear engines can be heard from incredible distances on clear, cold days. During the Cold War, NATO fighters would scramble whenever that familiar buzz appeared on radar. But often the sound reached air defense stations before the radar signature. Radar operators learned to recognize bears by sound before seeing them on screens. British RAF pilots who intercepted bears over the North Sea describe it as surreal. You'd close on what looked normal, then suddenly get hit by a wall of sound so intense it rattled your teeth. Formation flying with a bear requires special training. Fighter pilots approach from specific angles to avoid the worst sound and turbulence. The dance was always the same. Radar detected bears hundreds of miles out. That buzz would start reaching coastal listening posts. Fighters scrambled, climbing hard. By the time interceptors arrived, the bears would be cruising calmly outside territorial waters. Professional crews doing professional work, but with this undercurrent of barely controlled power. In 2015, the Tu-95 finally saw combat. After 6 decades of threatening the world, the Bear went to war over Syria. The irony is wild. An aircraft designed to nuke American cities ended up launching conventional cruise missiles at Syrian targets.
Russian Defense Ministry videos show these Cold War relics launching modern cruise missiles at 21st century targets. The contrast is surreal. Aircraft that belong in museums, carrying satellite-guided weapons. The cruise missiles are marvels of modern tech. GPS-guided, terrain-following, virtually unstoppable. But they launch from an aircraft with mostly analog instruments. The NK12 engines keep turning, keep making that sound. Crews still wear heavy headphones just like their predecessors did decades ago. Modern mission planning involves computers, satellites, and digital communications. But the basic aircraft delivering these weapons dates back to the 1950s. Russia expects them to serve until at least 2040. The first upgraded Tu-95 MSM flew in 2020. Russia is fitting them with modern electronics while keeping those legendary NK12 engines. The upgrades are wild. New radar, modern navigation, and updated defenses, all bolted onto an airframe that predates the moon landing. Syrian rebels learned to recognize the sound just like NATO pilots decades earlier. When that buzz appeared in the sky, cruise missiles were coming. The sound became a warning. An attack was imminent. Even with modern upgrades, the basic character remains unchanged. They're still loud, intimidating, and impossible to ignore.
Today, the NK12 remains the most powerful turboprop engine ever built. Nobody has topped it in 70 years. Modern engines focus on efficiency, quietness, and environmental friendliness. The NK12 represents a different philosophy. Why hasn't anyone built something more powerful? Nobody needs to. In our world of stealth and precision, the bear represents something from a different time. Modern military thinking emphasizes stealth and surprise. The NK12 is the opposite of everything modern air forces want. The Tu-95 is the only turboprop strategic bomber still flying. When it finally retires, the age of the super turboprop ends forever. But that retirement keeps getting pushed back. Every few years, Russia announces new bear upgrade programs. They modernize everything except the one thing that makes it special, those screaming NK12 engines. Somewhere above our planet, those NK12 engines are still turning and making that sound, and they're still reminding us that some machines are built not just to work, but to announce their presence. The bear's persistence says something about engineering philosophy. In the West, we replace things when they become outdated. Russians keep upgrading the same basic design decade after decade. The NK12 represents something we've lost in modern aviation. In our quest for efficiency and stealth, we've forgotten the raw, primal power of a machine and hide what it is. For 70 years, this engine has been a track of power projection. Of the Cold War, conflicts, that distinction has meant the same thing. We are here, we are strong, and we are not going away. The NK12 is more than just the loudest engine in the world. It's the sound of an engine that refused to be quiet. The sound of engineering pushed to its absolute limits. The sound of that was built not just to fly, but to be heard. And has certainly heard it.
That's the incredible the Soviet NK, the loudest engine in aviation history. This deep dive into Cold War, hit that like button. More stories of the machines that changed history. Share this with anyone who loves the intersection of engineering and power. And let me know in the comments what other Cold War machines you'd like to see covered.